waited one more person.
Can I volunteer to be the troublemaker in the class? It's kind of it's what I'm good at. It's what I did for 12 years.
You are an expert.
I need to learn from the best.
Isosceles triangles.
Okay, so today we're going to pick up where we left off yesterday in our high school trigonometry class, where we managed to just barely touch on some of our trigonometric functions. So when we're dealing with a right triangle, can anybody tell me some of the terms, ideas that come to mind? Tina. Okay. Kayla.
That was the one thing she knew.
Kayla, you done now?
Yeah, I'll put up another one.
Play.
Three sides.
Alex.
Acute angles. Acute angles. You're cute. That's a pseudo community right
A squared plus B squared equals C squared?
I was jumping a little bit ahead on that one, being as we're not quite that far, but quite Kristen. Well, triangle does have to be 180. 45's maybe it could be a 45, 90 doesn't have to be.
Find X.
All right. We have to see that one. Anybody else have anything? Okay, so out of this list, we have a whole bunch of terms. On your papers, you got these three blocks that are above and below your triangle. Now, Dina, since you brought up SOHCAHTOA, can you start with what the S stands for? Sine. And what would the O and the H be?
Opposite.
Okay. Now, if we have SOHCAHTOA and you've got 6 blocks, 3 above and 3 below, I want you at your tables to try and figure out as a group what the other 5 blocks are.
What is A stand for?
I know what the terms are. I don't know what
Oh, and then cosine.
big science.
Is it this symbol that you're
There's like
No, that's theta.
options like sine, and that's the cosine.
Yeah, it's a 28. So
You know, just thought of something else. squared plus b squared equals 2ab plus
I don't know, really math major.
They go with like the opposite, so science.
Which one's the opposite?
I like
So these makes it, I'm glad we're having the same So you switch these. Yeah, because you're taking the inverse of that.
I hope this is our cotangent.
Stomach math questions. Maybe not.
All right, we're going to bring what you have so far. If you're not done, that's fine. We'll be working through it. Can somebody tell me what they had in one of their other boxes? Go ahead, John.
Cosine.
Cosine. And the cosine was what?
The adjacent over the hypotenuse.
Good. Anybody else? Go ahead.
Tangent, and that is opposite over adjacent.
Good. Go ahead, Russ.
Cotangent, the adjacent over opposite.
Good.
Cosecant,
Okay.
and then it's hypotenuse over opposite.
Very good. And what's that last one?
Secant, which is hypotenuse over adjacent.
Now, can anybody see any connections between our 6 trigonometric functions? Right,
The ones at the bottom are the inverses of the ones on the top.
okay. So can you explain further by what you mean by inverses, that what you have there?
The denominator of the equation on the top is the numerator of the equations on the bottom.
Okay, vice versa. So, between these two, we can make a connection that those are the inverses of each other, which essentially ends up meaning that you have 1 over your cosecant is equal to the sine, and likewise for the cosecant, you have 1 over the sine. We can do that with each of these. So cosine would be equal to 1 over your secant. Your secant
This stuff sucks.
What was that phrase? Did you have anything to add?
This sucks.
Bear with me, see if you can make a connection in the end. Now your tangent would be equal to 1 over your cotangent, and your cotangent is equal to 1 over your tangent. So we have all these connections here. Now, does it matter which angle you're referring to in your triangle? Why? If it's this opposite over hypotenuse, adjacent over hypotenuse.
Well, if it's engaged the angle that's adjacent to your 90 degrees, then the opposite side is
So something like, if I label this one as A and this one as B, where would your opposite side be? For sine of A, let's call it, we're looking for the sine of A. This one over here?
Yeah.
All right. You label this one as the opposite. And where's your hypotenuse?
That long one.
Is there a wrong one?
No, he's the long one.
Oh. In a right triangle it is, you're absolutely right. If it's not a right triangle, then the long one doesn't necessarily mean that it's a hypotenuse and it's regular. So the part that people end up getting confused by is they like to try and label a triangle based on only looking at one side, but you have to remember which side you're looking for. So in this case, we're looking for like the sine of A, and you would have your opposite over hypotenuse. If you're looking for the sine of B, you're automatically going to have to switch, and this side now becomes your opposite, and your hypotenuse stays the same. So you have to make sure you remember to determine which angle you're actually looking for.
You take the sine of the right angle?
You can in theory, but here's where it gets a little confusing, because if you're taking your opposite, we'll label this one as C, you're taking your opposite side over your hypotenuse. So if you have the same value over the same value, what do you end up
You
getting?
get 1.
You get a sine of 1. Very good. Good observation. Now, Sean, is there any issues you're still having with our class?
No, I got it. I'm on it.
You got it? Is there anybody else that has any questions? No? So the process we just took here was called mapping. There's a lot of, some people learn this very differently from others. Some people absolutely love SOHCAHTOA. To them, as soon as they say that orally, that just sticks and they understand it. To me, SOHCAHTOA always kind of confused me more. I actually like seeing the visual picture of things. So remember, you don't have to do it just one way. You can try to make some of these other connections, and mapping is one way to do that. Thanks.